All right, we just had an introduction to the XY plane, and we have plotted some points and looked at coordinates. What I want to do now is I want to take a look at an equation where we're going to be using the XY plane. So our problem is going to be sketch a graph of y equals 2x plus 1. Now, we have solved equations before. Usually when we solved an equation, though, our equation only had one variable, like x. And when we solved for x, we might get something like x equals 3. But that's not going to work for a solution to this equation. X equals 3 doesn't make sense as a solution. Why is that? Well, because this equation has more than just an x, it also has a y. So any solution is going to have an x value and a y value. Now, I said x equals 3. That was just something I kind of made up. But what if x was equal to 3? What could we do with that? Well, we could plug in 3 for x, and then we could use order of operations to figure out what the right-hand side was, and then we would know what y is. If x is 3, we could substitute that in. 2 times 3 plus 1. 2 times 3 is 6, and 6 plus 1 is 7. So if x equals 3, then y equals 7. So one solution could be x equals 3 and y equals 7. All right? But that's not the only solution. I just said x equals 3. I just pulled that out of nowhere. I could have said x equals 2 or x equals 7 or x equals negative 63. And for each of those values of x, we could plug it in and figure out what y is. So what we're going to do is we're going to pick a few values for x, and we're going to plug them in and figure out the corresponding values of y. And we're going to list those in what we call a table of values. So we've already seen if x is 3, then y is 7. All right. So we're going to pick some more values for x, and we're going to plug them in and figure out what the corresponding values of y are. And you'll see in just a minute why this is going to be important. So this is a table of values. What I'm actually going to do is I'm going to make one more column, and this is just going to be the column where we show our work, where we actually plug in x to 2x plus 1. So let's pick another value for x. We picked 3. Let's pick 2. So we know that y equals 2x plus 1. So we need to plug in the value of x here. We said x was 2. So this is going to be 2 times 2 plus 1. Well, 2 times 2 is 4, plus 1 is 5. So that tells us y is going to end up being 5. All right, let's try x equals 1. If we plug in 1, this is going to be 2 times 1 plus 1. 2 times 1 is 2, plus 1 gives us 3. So if x equals 1, y is going to be 3. We're going to plug in a few more values. I'm actually going to pick 0, negative 1, and negative 2. If x is 0, then we've got 2 times 0 plus 1. 2 times 0 is 0, and then 0 plus 1 is 1. So this is going to be 1. All right, let's plug in negative 1. 2 times x, which is negative 1, plus 1. 2 times negative 1 is negative 2, because a positive times a negative is a negative. So we've got negative 2 plus 1. Well, that gives us negative 1. And then lastly, we've got x equals negative 2. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So we've made a table of values. We could keep going, but we're going to stop here. We just want a handful of values. Now, each of these has an x and a y. Now, we've seen something that involves x's and y's quite recently. And like magic, here it is, the xy plane. This is a nicer one that I actually created previously. a computer-made one so that you don't have to deal with my bad handwriting. And in fact, I recommend that you always use graph paper when you are graphing lines. It's going to make much nicer graphs. You're going to be able to read them much more clearly. Your group mates are going to be able to read them much more clearly. Your life is going to be much easier if you're using some sort of graph paper. So please use graph paper. Anyways, every time we have an x value and a y value, we know that we can plot that as a point. So this first one is 3, 7. We can plot that point on the xy plane. 3, 7 means we go to the right 3, because that's the x coordinate, and then up 7, that's the y coordinate, and so that is going to be the point right here. That's our 3, 7. The next one we have is 2, 5. That means we go to the right 2, we go to 2 on the x-axis, and up to 5 on the y-axis, and that's going to end up being this point here. Continuing, we've got 1, 3. That is to the right 1 and up 3. That is going to go right here. The next point is 0, 1. That's going to go right here. We've got -1, -1. That's going to go down there. And -2, -3 is going to go to the left 2 and down 3. It's going to go right there. All right, we have several points, and each of these represents a solution to this equation. However, these aren't all of the solutions. We only picked 6x values. In fact, there are infinitely many solutions. We could pick any number for x and multiply it by 2 and add 1 to get a value for y. So there's going to be an infinite number of points that represent solutions. However, it would take an infinite amount of time for us to figure out each one of those individually. So instead, we look for a pattern. Do these points have anything in common? Well, they happen to fall on the same exact line. And in fact, this line represents all of the points that are solutions to our original equation. Every single point on that line is going to be a solution. So we're going to draw in that line, and I'm actually going to label this line y equals 2x plus 1, because this line represents all of the solutions to that equation. This is the graph of that equation. Whenever we have an equation with x and y, we can figure out what the graph of it is going to look like, and that graph represents all of the points that are solutions to that equation. This is a big thing that you're going to be doing throughout your algebra classes, throughout trigonometry, calculus, if you end up taking calculus, statistics. Generally, we like graphing because it gives us a geometric way of looking at something that starts off algebraic. All right, this is just one example. I want you to look at some of the videos that are linked below for other examples, because some of them involve fractions on the x, and we have to be a little bit thoughtful when we're dealing with fractions. So look at a few of those examples to get more practice. If you get the first couple correct and you're confident, try a couple on your own and then check to see whether or not you got it right. And please put in effort to make nice graphs. If you've got a ruler, use it to make a straight line. If you're making tables of values, have at least 5 points so that you can really connect the dots nicely and smoothly and make sure you've done a good job. Sometimes students only do 2 points on a table of values, and then they end up drawing a really crappy graph, and that makes me sad. So please, just put in effort drawing nice graphs. It's really good practice. If you ever end up being someone who puts graphs in magazines and you draw crappy graphs, you are never going to get another job again. So, perfect.